Okay, so good evening, everyone, and welcome to today's VKC cluster seminar. And thanks to everyone for joining us today. My name is Amy Maley, and I am a master's student at UBC, and I'm this year's VKC host. I also have with me here virtually Maya Kopolova, who is our convener. VKC is a series of seminars for diamond geology and related topics, and our goal is to bring academics and industry professionals together. I would also like to acknowledge SRK Consulting for being a long-standing VKC sponsor. And just to share a few Zoom housekeeping notes, just please make sure that your microphones and your cameras are turned off for the duration of the presentation, just to ensure a good quality of streaming. The presentation will be about 50 minutes long, and please keep your questions until the end, at which point I will help to facilitate a question and answer period. And then after that Q&A, we'll move on to a more informal virtual social hour and stop recording. So now I would like to introduce today's speaker. So I'm happy to introduce Professor Jeff Harris as today's speaker. Most of you are probably familiar with Professor Harris, but I'll give a brief introduction to those of you who are not. Professor Harris completed his PhD at the University of London. Then afterwards, he went on to have a prolific career in academia. He was a professor at the University of Glasgow in Scotland and published 150 papers. His research focuses on diamonds, in particular diamond inclusions, and the physical and chemical characteristics of the host. Professor Harris was one of the organizers of the International Kimberlite Conference in Cape Town in 1973. The International Kimberlite Conferences, or IKCs, are special events which take place every 4 to 5 years. The first IKC was heralded as a major breakthrough in symbiotic cooperation between industry and academia. Professor Harris has also done a lot of work as a consultant in the diamond industry, most notably for De Beers from 1976 to 2006. Professor Harris has recently retired, but holds the title of an emeritus professor in Glasgow and an adjunct professor at the University of Alberta. So with that, I'm going to pass things on to Professor Harris here. So I will stop sharing my screen, and then I will get you to share your screen there again.
Well, good evening, everybody. This is an unusual event for me, being retired. One is swept into the 21st century in a big way. Tonight, I'd like to tell you about the diamond deposits of Namibia as seen through the visits that I have made, and also to include in the talk a history of Namibia with respect to its diamonds and its general evolution. So, a brief history would be that there was a nation before 1884 in Namibia, but it became a German colony at that time, which progressively did not suit the Namibians, and there was a progressive occupation and a rather horrible war of occupation in 1908. And shortly after that war finished, diamonds were discovered near Luderitz. We'll see where Luderitz is in a moment. And an area called the Speergebiet, or Forbidden Zone, was created. It was redrawn subsequently in 1921 for reasons which I'll outline. Diamond production continued until the beginning of the First World War, when Namibia was invaded by South Africa. And after the war was over, Namibia was administered from South Africa, and it was known as Southwest Africa. And in 1919, Sir Ernest Oppenheimer bought out all the German-owned diamond mines, established Consolidated Diamond Mines of Southwest Africa. And by 1923, he had the sole diamond mining rights in Southwest Africa along a coastal belt from north of Luderitz to the Orange River mouth, which was a colossal distance of 320 kilometers. This is where we are. We are north of South Africa. and west of Botswana. The area that we're going to be considering essentially runs from the Orange River mouth all the way up to Luderitz. But as the diamonds were initially found in the north, we're first of all going to go from the north down to a place called Chamois Bay, and then go up the lower reaches of the Orange River and come down the Orange River and go back to Chamois Bay. So there are particular reasons for doing all this. I don't know whether any of you looked at Namibia very carefully, but in the far north right-hand corner of Namibia, there's a bit of land that stretches out to apparently nowhere. This is known as the Caprivi Strip. It's a geographic salient created as a result of the German colony and the British colony in 1890 coming to a deal. The deal was that the German colony wanted a route to the other colony in East Africa. And so the British gave them a chunk of northern Botswana, and they received the island of Heligoland in the North Sea, which for the British was considered a strategic work. Unfortunately, nobody bothered to tell anybody about the Victoria Falls. So in fact, it was never used to get from the west to the east. The area of the southern coastal mines here really occupy a very small proportion of Namibia, as you can see. But we're going to be considering the diamonds now from around Luderitz down to Chamois Bay. There is one, this gives you an impression, I hope, of what the boundary fence looks like. This is the boundary fence looking south, and this is a roadway just to check that the boundary face is in order. Anybody who gets this far and gets across into here really stands no chance unless they have a great deal of water. You'll notice that there is no particular shelter, and the area is very inhospitable. If you look at a satellite image, a composite, but nevertheless a satellite image, there is a governing factor in all this, in the Dharma deposits of Namibia, which is outside, principally the evidence for which is outside the mining area. You will notice that this image here, that the strike of most of the rocks tend to be approximately north-south, as does the wind direction. The wind direction is essentially a southerly wind, which is just west or east of that division. North of Luderitz, over here, for example, is what's known as the Great Sand Desert. And this Great Sand Desert is perhaps the oldest sand desert in the world. Some people have estimated it's 55 million years old. And its creation is essentially because of the configuration of the geology here and the wind direction. And what it has done is it's fed by two sand corridors at Chamois Bay. That's why we're going down from there and then round to Orange Mine. And this one is the inner one coming up, and this one here is the outer one coming also into Luderitz. This is the Great Sand Sea. This is approximately 300 meters high. These are probably acacia bushes, but this is a huge accumulation of sand over a great deal of time. And how did it get there? Well, we talk about prevailing winds, and this part of the world between October and March is one of the windiest places on Earth. The average speed is, as it says here, 50, 60 kilometers an hour, but often it gets up to 90 kilometers an hour. It's a very active aeolian environment. Major movement of sands is possible. Barken dunes, which are considerable dunes, might move 30 to 60 meters a year. And from the point of view of our subject matter today, diamonds, They're capable of saltating 1 to 4 millimeter grains of garnet and diamond, and the grains can be sorted by size, density, and shape, and it creates deflation surfaces. And if any of you wish ever to read a PhD thesis on all aspects of this particular subject, then you should go to Ian Corbett's PhD of 1989, which is a freedom is free. You can just write Corbett PhD thesis Cape Town and you'll get this 400-page epic that he wrote in 1989. So now that we've set the scene, here's the Great Sand Sea, here's Luderitz. As a consequence of finding diamonds in 1908, the town of Kolmanskop was created. This is about 10 kilometers inland from Luderitz. This is a mine, what do they call it? Mini railway. It was once pulled by donkeys, but then they got some engines to run it. And this, because this is a very, very dry area, there is immense preservation of this town, which was started in 1908. This along here represents the edge of one of the sand routes north. So we'll have a look at some of the structures in here. The preservation is really quite remarkable. These were managers' offices and managers' houses. The water, of course, as always, is from tanks at the top. Here is the sort of focal point of the town. In here, there would be a dance hall, a casino, and the German people liked to go bowling. This is a bowling alley as well. At the moment, the town was abandoned in 1956 and is now a museum, and you can actually go and, I'm not suggesting wander around these places, but you can actually see some of these structures as museums. If we're going further south, we're now leaving the town, and these would be some aspects of industrial development associated with the mining operations. So we're now going to go south to perhaps one of the sand corridors. The early diamond mining, it was so simple that all you needed was a trommel and a workforce. And this was the residue from the trommels. And the next slide shows not from a postcard, but this was taken in about 1989, it says so. And these were the residues of the trommels, the waste from the trommels, which had then been flattened off a bit due to the wind that blows up through here. 25 kilometers south, we come to one of the original coastal diamond mining villages, which was built in 1911 and closed during the World War I. It was reopened in 1915 and finally closed in 1948. And this was the structure. You can see how you've really got no vegetation, nothing, just houses and companionship of the people who happen to work here. This is a worked out area of sand. So here's a scale. These were the German workforces, houses. Again, they're amazingly preserved. And this was their clubhouse. Now, apart from the fact that it's got a roof missing and a few bits and pieces missing, you can see that this is where the workforce, after we come for a drink. This also had a bowling alley, a casino, and a theatre. The important thing, though, I suppose, is for you to look at the front of this. This is a substantial structure. And this texture in here is due to sand abrasion, just to give you some idea how severe some of these winds can be and the damage that they can cause. This housed the Namibian workforce. That is a toilet. And inside here are a set of pens, which were the sleeping quarters of the Namibian workforce. Not perhaps a very happy story, but that is part of the story. The southern block of eBay in 1992 was again decided that there were sufficient diamonds in this region that they could start mining. Here's the recovery plant. This is the sand tunnel. And here you have just strip mining, taking out diamonds and sand and taking them and transporting them to this place where the diamonds were recovered. Again, these are some of the diamonds. The diamond production at this part of the diamond fields is very small. There usually are about 6 or 7 diamonds a carat, so therefore these are 2 to 3 millimeters in size. The plus side of this situation is that there were always gems. There was virtually no bought. It was 98% gem and 2% near gem. If we move from Colesman Cop and Elizabeth Bay and head further south on our initial journey down the sand corridors, we come to a place called Pomona. En route to Pomona, this is the side of the Edel Tal Valley. This is an ephemeral stream running through here, and this is a deflation surface. This is the narrow gauge railway line running through there. Now we're going to be here and having a look up the valley. There's the railway line. Now this was a huge deflation surface, and millions of carats of diamonds were removed from here. It was suggested, it is a fact, I think, that on a moonlit night, you could go out here and collect diamonds. This, in a working day, was how you would find diamonds on a deflation surface. Around each of the necks of these people was a small pouch, and they would crawl across the ground, as you can see here, and any diamonds they found, they would put in the pouch. So here they are looking for diamonds. Now this is a deflation surface of garnets in this area. And I suspect that the early pioneers who wandered across this land looking for diamonds probably had surfaces looking like this. Immense amount of small diamonds and garnets. This is near a beach, as you can see, but it's a deflation surface, which has highlighted the higher density garnets, as it would do with the higher density diamonds. This slide shows the next mining site at Pomona. These are again the German area. Here, perhaps in the sand corridor, you had a recovery plant, you can see from here. And the edge of the corridor is here. So these mines were at different points along the sand corridors. This This was the cookhouse. And again, you're beginning to see these very funny structures, which represents the sleeping pens of the Namibian workforce. The houses in this part have been lost to the desert. If we follow the railway line further south, it required sort of stations where water and coal could be put into the engines so that they would function. But it's an amazing piece of German organization to plot this thing correctly going down south. And the next village or the next town or campsite is Bougainvilles. This is the mine manager's office as it looks now. This is a toilet block. This is a colleague of mine for scale. And again, the diamonds were found there. And most of the houses, because of the wind, would look like this. Perfectly preserved wood, but now filled with sand. And you can see how, even inside a house, you have ripple marks. This is a desalination plant in Bougainvilles, and if you scratch around, you can find coal, which had to have come from Germany. Principal geographic feature of Bougainvilles is the Bougainvilles Arch. This is where the desalination plant is. And as you can see, there's a road comes in, it turns round. Now, this is supposedly a national park, which should allow access for people. But it would be very difficult to get down here without some serious permission because of the diamonds are more important than the tourists. There is a nice path running up here, but just in case any of you who are listening actually get to Namibia and actually get to the Bougainvilles Arch, be warned that just off the path, there's a hole that does actually go through there. A child probably wouldn't make it. A man or a woman might just be able to put their arms out to prevent them from falling. So if any of you are so enthusiastic about visiting Namibia now as a consequence of this talk, and you get to this place, please be careful walking up this arch. These are the Bougainville diamonds in 1992. Again, 5 or 6 stones to the carat, but they're all gem. And it was the gem diamonds that they were after. So if we put this first part of the talk into some sort of production, and bearing in mind things 1914, there wouldn't be any production. The number of diamonds that were found in between 1909 and 1913 were colossal. This 1.5 million or thereabouts was only ever reached again in 1962. They supplied in 2012, 12% by volume of diamonds, and by 1913, 20%. It was a very serious mining operation. So what we're going to do now is wander further south to Baker's Bay and Chamois Bay to show you the beginning of the sand corridors, just so that you get some idea about it. This is Chamois Bay, more or less. Here's a boundary fence of some sort. And you can see here how you're beginning to get a corridor of sand. This because of a configuration of the coast with respect to the prevailing southerly winds, which are running from left to right. We're going to go a bit further out to this particular bay and have a look at how it all works. So here we are. You will note as we go across this first sand corridor to the one we're interested in, how quickly a sand dune forms once it's on the land. diamond doesn't wet, so diamond and sand come out onto this beach. The wind dries them, the wind picks them up, and off they go on a lifetime's journey. This one is particularly good in one respect, in that this is the prevailing direction of the wind, as you can see, which is very good for depositing material on here. This is quite wide. I don't know how many kilometers it is, but it's measured in kilometers, as you'll see from this. This perhaps is some minor trench work that was done. This may be a track of some sort. So here's these Barken dunes charging along, but unfortunately this particular section of the coast is an even bigger bay, so having got themselves onto the land, they trundle along to the end and then go back in the sea and come out shortly further up the coast. But this sand fed the great sand sea north of Luderitz. It's obviously been disturbed now by these mining operations, so I can't say how much sand actually gets there anymore. At least that's what caused the Great Sand Sea. So if we consider our history, it was in the late 1920s that diamonds were recovered from the south and north banks of the Orange River. And then there was some small-scale mining. Large-scale mining commenced after the Depression of 1933-35. Between 1936 and 1990, Consolidated Diamond Mines, which was run by De Beers, managed the alluvial operations in Namibia. The first offshore licenses were issued. If someone wants to know about that, it's not particularly part of the talk, but if someone wants to know, that is where the future of Namibian diamonds lies. It does not lie on the land, but in the sea offshore. Okay, finally in 1990, Namibia gained independence, and in 1994, a NAMDEP formed from Consolidated Diamond Mines as a 50-50 venture. And over the 80 years up to this creation, 65 million carats of diamonds were produced with no poor quality stones. So what we're going to do now is go to the mouth of the Orange River and go a bit upstream from it and talk about the mines in the lower reaches of the Orange River, and then go back up to Chamois Bay. So we're going to go from here now and wander off down here and go to somewhere around here. So we're going to start here. You'll see what happens in a minute. This is a satellite image of NASA and the very meandering Orange River. Now, while great rivers around the world often have great meanders, they don't normally have meanders incised in quite a substantial terrain. This is not lowlands. This is a mountain range, which illustrates the force, in the past at least, and the energy that has passed down this river in order to create these immense meanders, accompanied by oxbows subsequently. And it's in the oxbows of the lower reaches of the Orange River that diamond mines were created. On the northern side, they would belong to Namibia, and on the southern side, they belong to South Africa. So you actually had high-level terraces or oxbows, as in this case. And we're just going to have a look at perhaps Arcus and maybe two of the other ones up here. The diamond mines, when I last went to this region, were owned by Transhex, but I think that has changed subsequently. Now the energy in the Orange River had to be immense in order to create this. This is not some pile of pebbles moved from one place to another. This is a pebble bed on top of the Orchest Mine before you got to the oxbow and the bed of the Orange River, where most of the diamonds lay. you've got obviously clays and then fine grain, coarse grain sands. These lips are at least 10 or possibly 12 meters high. This gives you some idea of the scale of things. And this is about the equivalent of a 25-cent Canadian piece. And this, therefore, is a considerable boulder, just to show you the immense energy that existed in this river. We'll talk about very briefly subsequently. So here we have the Orchest Mine. This down here, where you actually see some rock, is the base of the oxbow on the on the bed of the river, formerly on the bed of the river. And these are 10 meters high, got 10, 20, 30, 40, 50, 60, sort of 90-meter high stripping operation in order to get down for this. And we're talking about inside here 1 to 2 carats per 100 tons. The other thing, at the bed of the river, you can see how uneven it is. And in particular places, there's these huge potholes, which again may be very rich in diamonds. Here's an example of one. Here's a typical I know them as a baccy, but then we call something else in this country, but they're a truck of some sort. And then there's this huge pothole, and then in the middle of it, there's a very narrow one, which may even carry more diamonds. But all this is dug out and taken away for assessments. If we ask ourselves, when did all this happen? Clearly, the diamonds of Namibia come from South Africa. And if one was slightly philosophical for a moment, this must be one of the greatest gifts that one country has ever given to another. The people like JJ and Grobler in 2019 done an immense amount of work as to when the diamonds reached the coast on the grounds of shells, fossils, and all sorts of other things. And they drew out this rather splendid diagram. So we'll first of all start with the carats, with the weight of the stones. They estimate that in the Eocene 42 million years ago, the first diamonds arrived, so-called easily moved fine mobile diamonds. They bounced down from the interior, and they had a stone size which was approximately half a carat. And through time, the stone size steadily increased, so that about 3 million years ago, you had the very coarse tail of diamond population, which slowly made. So these were the 50 to 100 carat stones that made it without breaking. The grade, which is how many carats per 100 tons, appears to have peaked around 30 million years ago, when there were 30 carats per 100 tons. And then they steadily moved down to about, say, 4 or 5 carats per 100 tons, and now they're down to 2 or 3. I love this diagram because it must have really been very exciting for these people to be able to put the whole of this thing together in this way. Oh, it's here. This is an aerial photograph of the mouth of the Orange River. This is the town of Arrangemund. And our mines, we've just evaluated, are just up here somewhere. And this is when it's in flood. And the fine grained sediments in the past, along with their diamonds, would come out into the continental shelf along here. And as you can see, the longshore drift of the Benguela current moves them north. So this kind of area, this is 10 to 50 miles out, will be sprinkled with diamonds. And in the past, the assessments have been made that if there was about 3/4 of a kilometre of land taken off the 4 principal mines in Kimberley, and they swept into the Vaal and then into the Orange River, there are still millions of carats of diamonds sitting on the seafloor offshore of the Orange River or up the side. Now we're going to go up here. These dark patches here are known as paddocks, and these ones happen to have been flooded. You see the same color there, there's the same color there. And the mining operation in this part of the world, up to Chamois Bay, is through paddocks. And we're going to talk briefly about paddocks. So the Orange River mouth, again, this wonderful paper, which is in the Journal of Gemology, by the way, if anyone's interested. The only thing that happens between here and up to Chamois Bay is that the diamonds reduce in size. So the large diamonds haven't got really into gear yet to get up here. In the old days, they used bowl scrapers in order to clear the sand in order to get to the rock face, to the surface that they wanted. Nowadays, this bucket excavator and stacking conveyor is more typical. This is mined out ground, and the object of the exercise is that this huge excavator takes sand, passes it over an area here, which has been, the sand from the sand has been taken off, but it's not been yet mined, and piles all this waste onto the mined out section. So this is the kind of bucket excavator, giving you some idea of scale from this backy here. And then the diametriferous gravel surface is here. You can just see a few pebbles, perhaps quite large ones, but nevertheless pebbles along here. Once you get to the bedrock is not simple. It's metamorphosed hornblende and various other terrible rocks that do not give flat surfaces. And so in order to get into the crevices of all these, diverse pumping methods are used. Here's the overburden, and as you can see, that's a standard lamp, a standard pole of some sort. It's been quite a lot of overburden. And so they get into all these things and pump out the material, some of which is diamondiferous. This is the first time I went to South Africa and into Namibia in 1969. It was in July. I would warn you that it's always very cold in that part of the world in 1969. But again, these vacuum cleaners were removing the finer material or the material between the various layers and weathering of the country rock. When you came to the sea front in 1969, they built a sand wall and they put dentates across the top of the sand wall. These are pumps driving out the groundwater that emerged on this side of it. And you can see how old this picture is. This is a bog standard Land Rover. We don't look like that anymore. And here's the scrapers. And if a scraper got stuck, a bulldozer would push it out. What it was meant to do. So here are some dentates on a rather aggressive South Atlantic Sea. Here are the pump ends where they're pouring water out back again. It's a bit more modern than this now, but it was a bit hair-raising from time to time as the sea did in fact come over the wall. One of the advances that has been done fairly recently has been to push the sea wall out to sea so that they could actually mine below sea level to quite some distance, 10 or 12 meters. And that would be done by, first of all, accreting a beach. And that beach would be approximately 2 meters above sea level. And then they build a wall. And although this was the sand they'd already put there, it was very easy to remove it. And so that progressively they would then be able to start mining behind the seawall. And so this area in here might be 10 meters below sea level. And one of those is kind of shown here. Because they can move so much sand so quickly, but I also should point out the sea can move some sand so quickly that someone would check this from time to time to make sure that there was sufficient height to the wall so that no one was in danger. And looking the other way to the left of here you have your sea wall. And then they're removing the sand from here. Here is the exposed and stripped material. And they just move it. It's just a huge sand movement. And they make them into paddocks so that they'd have a wall at the sea and then a wall coming in 2 or 3 places. And this was entirely that if one part of the seawall was breached, then it would only be one paddock that would flood and not flood the whole of the area behind the system. Fairly standard exposed material, so on, and here they have just a massive removal of material to get down to the bedrock. And then in the bedrock, the people would come and take things out. Now, I suppose from 1969 to these photographs of about 2006, I suppose, there has been a quantum change in how they do this. Nowadays, these vacuum pumps go immediately into these places and the diamonds stay in there. These are very sophisticated cameras. You are not allowed as a visitor to pick anything up. If you want something picked up, you go to an employee and say, could you pick this up for me? They are very good at trying to preserve the diamonds that are probably sitting quietly in these regions. In 2008, there was a slight drama in one of the paddocks, which was 7 to 8 meters below sea level. Metal, such as shown here, blocked a recovery plant. The top one turned out to be caused by a bronze muzzle loading swivel cannon, and there was demi-sphere shaped copper ingots. So if you're only expecting sand in a recovery plant and you suddenly find this comes into it, then that's fair drama. And so they went back into the paddock to see what was going on, and they came across a great deal of wood. And wood is something that you do not find in the Namibian coastal belt. But this wood was clearly not trees. This was wood from a boat or a ship in this case. And it was discovered on the 1st of April, 2008. So here was the paddock that they were working. Again, the difficulty of getting diamonds out from these crevices. And here was the boat. And then it got even more exciting when they found these. There were over 2,200 gold and silver coins found. And they were absolutely beautiful, as you can see. The other thing they found was 44 ivory tusks. And so an investigation was set in train in order to find out where this ship came from and why it founded on this coastal belt. They did DNA on the ivy and found that it came from West African elephants. However, the most likely origin of this ship was probably Portugal or Spain. So these ingots happen to have a hallmark on them. Here it is. And we found 44,000 of these things. And they were able to identify this hallmark to a group called the Fugger family, which was a German Renaissance trading company with strong links to Portugal. Now, they eventually identified the ship as the Bon Jesus. But they had initial identification difficulties because historic marine records for both Portugal and Spain had been destroyed. In Portugal, it was the Great Earthquake of 1755. In Spain, it was through battles during the Civil War. And the ship, as I mentioned, was identified by trident hallmarks. The ingots belonged to the Fugger family. And one of the amazing things was that the Fugger records had survived 2 world wars. And they showed that a ship called the Bon Jesus set sail from Lisbon in 1533 as a flotilla of 7 ships on a trading voyage to India. And India documents indicated that the ship did not arrive. Now, technically, this ship, once it had been found and documented, belonged to Portugal. But Portugal very kindly gave the wreck to Namibia. And Namibia, I understand, are building a museum in Windhoek. Incident. So there we are, Namibian diamonds, 2 to 10 carat stones, 98% gem, 2% near gem. And that's my history, ladies and gentlemen, of diamonds from Namibia. And I thank you for listening. I'm not quite sure what I do now, but I'll stay quiet.
I can take it from here, Jeff.
There you are. Hello again.
I will.
There's my
There we go.
good.
Thank you very much for that. That was really, really interesting. So we're going to open things up now for a question and answer period. So you can either send me a question in the chat and I can ask Jeff myself, or you can just speak up on Zoom. I guess I'll go first. My question is what type of projects were you working on personally, Jeff, when you were working in Namibia? What was your role?
Well, my role was twofold. Well, the single role was to find out where the diamonds came from. I mean, it may be obvious now, but my boss was not of that type. He wanted evidence. He wanted to know for sure. And so one of the features was that we did classification of diamonds along with that work with Derek Robinson. We looked at surface features and things of that sort. We looked at diamond color, all in the hope of knowing where these diamonds came from. I think the most important aspect, however, was that if you take a chrome dioxide inside a diamond and you break it out of that diamond, you can measure the argon 39, argon 40 of the decay of the potassium. And we did a number of experiments which clearly showed that once the diamond has come to the Earth's surface, the argon did not diffuse through the clinopyroxene and end up on the diamond inclusion interface. And therefore, you could determine the eruption age of the diamond. So, as we collected a great pile of diamonds with chrome dioxides in, we did a study on the chrome dioxides of Arapa as a standard, because we knew that had erupted at 93 million years ago. And then we did a study on the diamonds of Namibia. And the diamonds of Namibia were 90 million years or thereabouts. And 90 million years thereabouts is when the Kimberley mines erupted. And that, combined with the shape of the diamonds, which were very rounded in terms of dodecahedron, things like that, we concluded that the diamonds were derived from the hinterland, and in fact from the Kimberley region, they were known as Group 1 kimberlites. So in this way, we were able to, I think, give a lot of strength to the identification of the diamonds, and that was basically what I helped do.
Interesting. Does anyone else have anything they'd like to ask?
Yeah, I have a question. I was interested in your comments on the saltation loads, and you were talking about the Barken sand dunes. And my understanding in the sand dunes, if I'm not mistaken, and if somebody please get the right answer, I think quartz is about 0.125 millimeters is like the saltation load in sand dunes, in quartz sand dunes, if I'm not mistaken. And it's kind of like when you're on a beach and the sand's whipping around and you feel the sand bouncing around and whipping around your ankles.
Yeah.
That's about the wind strength. And you mentioned that you get 1 to 4 millimeter size garnets and diamonds in saltation.
Yeah.
So where do you find those? And you mentioned an 80 to 90 kilometer wind strengths. So how strong are the winds there?
80 to 90 kilometers an hour.
And
the wind strength, I thought I mentioned the wind strength was average 50, 60 kilometers an hour. But it rattles up. These wonderful people who study saltation, they have I don't know what it's called, but they put up a pole and they put cups at different levels of it. And various sand grains pop into these depending on how light they are. And when Ian Corbett set up a typical column to check the saltation of sand, he only got half a population because he hadn't put the pole up high enough. And it was only when he put the pole up high enough that he realized the amount. So the fine grained sand that you're talking about, which tickles your legs on a good day, when one of the pieces of field equipment that you got when you got off the helicopter or whatever and landed in Namibia was glasses to protect your head, protect your eyes, and also sometimes they gave you earmuffs because the sand was that high. You were breathing it in. It was just eroding your face in some instances. So I have no problem really about that. That deflation surface was just by wind, the Garnet one. But just imagine if it was diamonds, and you did the first one who just happened to be there.
Right, and you mentioned Namibian Garnets, so can you please qualify what a Namibian Garnet is?
Oh, I believe these are bog standard garnets from the metamorphics of the area. They've been eroded from local deposits. I'm not familiar with what rock types are there, but certainly they didn't come bouncing down rivers and bouncing up coasts in this sense. So they were local, that just been eroded away, and off you go.
No, that's quite correct, Jeffrey. Yeah.
Hello,
They're
Bob.
local.
This is the young man
Good morning.
who found the boat. Just thought you should know that.
Yes,
Thanks,
well,
Bob.
good morning, Jeffrey. Yes, it's 3 o'clock in the morning here, but you're quite right. Ian's study showed that there were surprisingly large grains of sand and garnet and diamond, more or less the same SG as each other. He was showing that garnets up to 5 millimeter diameter would move very quickly during his experiments. Yeah, and the garnets are not kimberlitic garnets associated with the diamonds at all. They come from local rock.
Amazing.
I should say, Jeffrey, as well, that built on your early studies about diamond provenance, people like Mike DeVitt and John Ward and Spike Spaggiari have kind of widened the provenance area to include Western Transvaal, as it used to be called, the Lichtenberg areas, in addition to the Kimberley areas that you were mentioning.
Oh, that's good news, because we did get some values at around 140 million years. It was just that there was no 140 million years were prominent. If you went down into Namaqualand, the diamonds there on the Argon, they were around 120 plus.
Yep.
So I would expect in the north that you would still get the odd stone coming off the Western Transvaal alluvials, going over through Kimberley, joining the Orange River, going across down through the Gravies Falls and popping out and going up the coast. So that's quite good news. But for everybody who's listening, it represents how different aspects of our science comes in with people like Bob and those who are on the ground looking at samples of rock and realizing that this rock has to be 140 million years old. That's how it all comes together, and I'm very pleased that we have a common result. Yeah,
because back in the 30s and 40s, I think people believed that the diamonds were coming from kimberlites very nearby.
Oh yes, and I remember that when Barry Hawthorne came boss, a man called Waters, I believe, he believed that the diamonds came from kimberlites at the mouth of the Orange River.
Yeah.
So,
Marty, do you have a question? Your hand's up.
Yeah, I'm surprised to hear this 10-carat stones being recovered there on the coast. I've never heard of that size, and you mentioned 2 to 5 carats, 2 carat to 10 carat stones. So have these all come from the interior of South Africa?
yes, they just take a little longer.
Wow.
I mean, I can't remember. Bob may be able to know, may have some numbers, but certainly large diamonds, 50, 60 carats, were found around the mouth of the Orange River. They had to be of good quality. If there's any weakness, they probably wouldn't have made it. And they were yellow, and that was another feature of the Kimberley mines.
I'd like to follow with a question on those garnets. And that's probably quite unusual to have deflation surfaces fully covered with metamorphic garnets. And I'm wondering if has anyone thought about collecting those garnets and using them as semi-precious decorative material? That would be so easy.
Well, it would be. The problem is that it depends how close it is to the mining operation, I would think. The mining, they take security very seriously here. And I think that whilst the deflation surfaces may be known, and the garnets, as you say, might be of some use in some form of jewelry, I'm not quite sure how they could be collected. Mm-hmm. That's all.
Can I ask a question going back to what Bob and Jeff were saying about the origin of the diamonds? You were talking about the Lichtenberg area. Are you there, Bob? Have they found primary sources, or is that different secondary sources of the diamond that then moved down to the coast?
To the best of my knowledge, they haven't found primary sources that could be identified as kimberlite pipes. But you've got all these sinkholes. I don't know if you've been to Bakerville and the diamond deposits of the Lichtenberg area in general. But Mike DeWitt principally, but also supported by John, believes that the diamonds that are found in those areas in sinkholes may be closely associated with primary deposits, but yeah, the limestone wad that they're recovered in is so weathered that they can't identify a primary pipe, but it may not be too far away.
Interesting.
One other aspect of that was that as it is a Transvaal alluvial, I went to Klerksdorp, I think it was, to discuss with the buyers in the area whether or not they would allow us to look at their alluvial production to recover chrome dioxides. The idea being that if those chrome dioxides registered 120, 140 million years, then we had the likely source of the diamonds in Namaqualand. They showed interest, but it was clear that they didn't want to do it, even though at the time the De Beers company were offering a premium to buy a stone, because the stone was more interested for the date than it was for the value. So that operation was never successful, but if it had done, it might have answered Barbara's question and Bob's as well, because it's an absolute dead ringer for giving you an age.
So the origin of the Lichtenberg diamonds, the date of the source of the Lichtenberg diamonds hasn't been established. Is that what you're saying?
Yes, exactly.
Mm-hmm.
I mean,
right.
it's, pardon? Oh, yeah, it is. It's just, you just need 10, 12 diamonds containing chrome dioxides. End of story. Well, it's not end of story, it's the beginning of a story. The dams have to be broken out. They have to be sent halfway around the world. The guy's very busy, but well, you know. It's fun.
What's the future of the diamond production in that area? So
in Namibia?
In that particular area with alluvials and marine diamonds there. So do you see that continuing for tens of years? Do you see
not perhaps in its, not perhaps in their present form. The paddocks, they are working very hard to push the sea back as far as they can so that they can work behind it and get to the diamonds which are clearly there. But the equation may be that at some stage in the future, to scoop up diamonds systematically, and it is really a very high technologically and secretive process, how you put something down on the sea shore, on the seabed, sucking up sand and gravel and all the rest of it, and the ship upon it which it doesn't move, and there's a force 5 gale blowing from the South Atlantic. It's a very skilled job. But there is an ever-increasing proportion of Namibian diamonds coming from the sea operations than there are from the land. last year they produced about 1.6 million carats, but I don't know what the breakdown of those two, of that figure is in terms of sea diamonds, but that's where the future lies.
So you don't see the end of that, yeah? So they.
I don't see it. No, I mean,
yes.
I don't think so. I think there's a paper of John Gurney's. I think it was it was in economic geology, I think. He wrote a big paper on South African diamonds, and in it he assumed the loss of about a kilometer of kimberlite from Kimberley, and he projected up the pipes and the volume, and he assumed the same carats per 100 tons from the mines, and assumed then how much of this had gone down the river and took some off the total because it would have been destroyed. And he came out with millions and millions of carats over anything that the Namibian production had produced so far. But it was all in the sea.
Mm-hmm.
So I think that I don't know what the processes anymore are, but if there is production, it may be through the building of a couple of boats or ships which enable this process to go, but it's very sophisticated, and it can do it in deep water. But it's the rollers that they've got to watch.
Mm-hmm.
So these boats have at least 4 or 5 engines on them, front, back, sides, the whole lot, so that it keeps it absolutely steady.
I was interested in some of the ages you gave there, that the Great Sand Desert's 55 million years old. And if I'm not mistaken, the coastal deposition of diamonds started about 42 million years ago. So there's some sort of reasonably coeval ages happening there. And so what would that do to where the older diamonds are off coast?
Well, I mean, I imagine it simply as it's 815 miles from Kimberley to the Orange River mouth. So the diamond starts off one day, and 42 million years later, it arrives at the mouth. And it's a small diamond because it got there first. So that was what the caratage was. And then the longshore drift just moved it along the coast, not 320 miles, but something like 230, which is where Colesman copies are there. I mean, around there anyway. So it took another 40 million years to get to there. So yeah, it's really quite a dramatic journey for a diamond to survive that transport system, but clearly they do. And even beyond Luderitz, I went to a place in the middle of the desert. It really was in the southern edge of the Great Sand Sea. And De Beers had dug a series of trenches and recovered, looking for diamonds. And the diamonds there were microscopic. So even you could get this grade getting smaller and smaller. Oh, amazing.
So in that amount of time, are there any catastrophic flood events recognized, and would the larger diamonds be potentially involved in a more catastrophic flood event?
Well, I mean, my feeling about all this is that you've got some nice little diamond sitting quietly somewhere, and then there's a massive flood, and you're then in an energy environment that would move it further on down the river. The oxbows were really a very high energy environment. I mean, those pebbles were not small, and I would think that the vast majority, if the Lesotho highlands rose 42 million years ago, then the flow down the Orange would have been even more and even stronger. And I would think that in full flood, a fair proportion of those diamonds would float. They would float down the river. The energy would carry them. It would only be the larger diamonds that would do the saltation or get caught. If you got caught behind a piece of rock, there was nothing they could do about that unless the river swiveled and it swept them out. But I reckon many of those diamonds got down the river, in general terms, floating because of the energy of this environment they were in. And so I don't know, I can't say what level, what size they would be, but the smaller ones I've no doubt floated. So.
Well, a couple of 3 years of sampling rivers for indicated minerals and diamonds. We were surprised where we found some of our best results in modern, ephemeral drainages.
Yes, yeah, I think that they go into a lake which is given a name. It's a lake essentially where all the water goes in and none of it comes out, but it can evaporate. Arabo, that doesn't matter, I can't remember. And so the diamonds would be there, and then if that was then became a deflation surface, they would just accumulate. Sand would go, diamonds would stay. Oh, it was a fun time in Namibia.
Yes, and as you say, Jeffrey, the evidence is that the Orange River was, in the past, in the periods of the diamond movement down to the coast, which wasn't continuous, it was a very much more aggressive river than it is now. Present Orange River would be unlikely to excavate potholes or bedrock topography on a scale like you showed in your pictures, and that you see once you've excavated the sediments on top. Yeah, it was a very.
I was just absolutely knocked out when someone showed me that huge bloody great pile of pebbles with clay in it, and that was just what the river had dropped in this particular place. And Orchest Mine, I don't know whether the benches were 10 or 12 meters, but there were 9 of them. And you guys had just scooped all this lot out to get to the bedrock.
Yeah.
And yet, in spite of all that expense, it was economic.
Yeah, and just to Martin there, we could point him to JJ's PhD, Jürgen Jacobs' PhD thesis, which was on the Orange River, and you showed a couple of his slides there.
Yes.
Or him and Godfrey Krubbelar's slides, but JJ's PhD, Marty, would be of interest to you, I'm sure.
It would match the 1989 one in another aspect of the same subject. Yes, I should have mentioned that.
Ian's PhD was, as you said, on the coastal belt and wind strength, and whereas JJ concentrated on the Orange River itself. Yeah.
No, there's a cliff on the Orange River around Orchest, as far as I remember, and I saw the sun on it once, and the lower half of it was reflecting and the upper half wasn't. And I reckoned, on no evidence, that was a smooth abrasion of the river in the old days, and the top was where the river never reached, and it had smoothed off and abraded this. It was on a bend, so the water would really rattle into this. But I never got across the Orange River to see. Anyway, it's probably still there. All these things are still there.
Oh, Bob or Jeff, do the kimberlite indicator minerals, they never get this far, I presume, as to the coastal areas that were associated with the diamonds originally?
I don't know the answer to that.
Yeah, no, it wasn't. When I
I'd
was
be
at sea,
incredibly
we-
surprised, Barbara.
Yeah.
In Australia, our indicator studies, in modern sediments like chromites were the things that survive in Australia. They're chemically and mechanically resistant. If you're reasonably, maybe 12, 15 at most kilometers, there'd be a garnet. And within 1 or 2 kilometers, you'd have chrome dioxides. Very, very close. Because Australia was deeply weathered in the tertiary, so it really destroyed the garnets and the chrome dioxides, whereas the chromites remained stable. They weren't chemically destroyed through tropical weathering, and they're also more mechanically stable, so they could go 20 kilometers plus. And then you'd focus in on surface textures to see how close you were to potentially a primary source.
Yeah, I realise that, but the situation down the Orange River seems to be quite exceptional through its history. So I just wondered if any indicated minerals actually made it.
Well, I'm thinking, have you ever seen the Agravi's Falls in flood? I mean, it's an amazing wall of water just comes down into a canyon and pounds along. I mean, I don't know. I mean, the diamonds make it, but I don't know whether anything slightly different will. But
Yeah.
it was, I mean, I think that the people in Namibia would if any had been found, I think they would have noted it, because they did look at a lot of stuff.
I can't point to any serious search for Barbara for kimberlitic indicators in those sediments. I mean, I think we probably had a quick look in the 80s, but it was a pretty half-hearted search as far as I remember. So I can't say whether anybody's really looked in amongst you know, all those common garnets, for example, that Jeff showed.
I think also one of the things that they did look for was the Ventersdorf lava pebbles.
Mm-hmm.
And they noted where that was. That stuff got down, but you know, you'd have a pebble which was like that. So,
well, here's a question: how far down the Orange River would you find a kimberlite boulder? And if you get kimberlite boulders, you should be getting kimberlite indicators.
my feeling about all this is that the weathering in Kimberley was not particularly violent. The ground is very flat even today, and you've got these copies which represent the former weathered levels. And so I would think that the weathering of a kimberlite would not be to the release of great chunks of boulders running down a river.
Yeah.
But I don't know. And I don't think it would last very long, because it's, first of all, it would go into a soft rock and it would break. It's not a hard rock once it's got going. You know.
Oh, unless you got a HK.
Unless you got a hardy back. Okay, there are some.
Yeah.
Anyway. So there you are.
I'm going to have to say good night. I really enjoyed the history there. I think it's great, and it sounds like well, there's some interesting potential up still.
Oh yeah, I think we're all right for the while yet. But whether I'll ever go through the various X-ray processes to get onto the mine again is uncertain.
Sounds like some high-tech oceanic engineering required.
Well, I think it's there. I
Yep.
think some of the detection methods for looking for things on the sea shore is just short of submarine defense levels. It's pretty high.
Bob, is there any sense of life of mine of the ocean, of the marine diamonds?
Well, I don't have it.
No, I just wondered if you could guess or whatever.
Well, they maybe 2-3 years ago, they built a very state-of-the-art exploration ship. So there must be some confidence that it's going to prove its worth.
Right.
But no, beyond that, I don't know.
Mhm. Bye, buddy.
Oh, I get a prize. Fantastic, Amy. It was lovely.
Okay, I am going to stop the recording here if no one has any more questions. Let's see.